Welcome back, guys. My name is Brandon. Today we've got a repair project that we got to do on a brush hog or a bush hog. Let me show you what we're going to be doing. This is what we've got. From what I understand, this is attached to like a bush hog or a brush hog. It might have like a big blade underneath the bottom of it, and it's made to chop down brush and stuff. Basically, it's like a really big, gnarly lawnmower to chop down real heavy brush and stuff like that. I think that's the principle behind this. It was brought to me because you can see it's got a cracked weld all the way around it. Same thing on this side, it's cracked all the way around, and it actually looks like it's bent. If we flip this over, see this little lip right here? So this plate needs to be bent upwards. Then it's bent the opposite way over here. So this has to go down. And I think the way this works is that this bolts onto like the deck or the mower deck, and probably one side of this maybe has a pulley on it, and the other side probably has like a massive blade that does all the chopping. I asked him, can it be welded on this side, straightened and welded on this side? He said it couldn't because it's a real tight tolerance. So this fits through the deck and it's really tight. So if I put a weld there, that's going to interfere. So what that's going to involve is we're going to grind out the weld on this side, then we'll put it in our press and get it all straightened out, then we're going to re-weld it. Now if you look down on this, the only area where it's not cracked is right here to right here. And that's probably why it didn't continue to crack, because it's welded here. For you regular viewers, you may recognize this. I've had this in the shop before, and this arm had broken off from this. So I re-welded this back on. So the good news is my work didn't fail, but this did. And I asked him, what is causing these damages? And he thinks maybe what happened on this, his son might have hit a stump, and it just stopped everything quick, and it just caused this to crack and break. Let's clean this up a little bit and get this old weld ground off and get it drilled out. You never want to re-weld over a broken weld. You're just asking for problems. You always want to remove any old material, rust, or contamination before re-welding. Otherwise, it's just going to fail again. Clean metal is the key to getting strong penetration and a solid weld that's going to hold up over time. Now that we've got this old weld all ground out, the next thing we need to do is drill a hole through it at the end of the crack. And what that does is that prevents the metal from cracking beyond that. But when we straighten this out, it could reveal additional cracks that go further around. So before we drill the hole, I want to put it in the press, start straightening this out, and get it to where it needs to be. Then we can drill it, and we can weld it back together. I built this bending brake attachment, and I'll tell you what, guys, this thing is so awesome. I would not change a thing. I did this for myself, under $100. And I've got all the materials listed in that video if you want to check it out. But we're not bending a 90 in anything, so we can get this out of the way. And we need to press right in here so that it pushes this further through that plate. Keep your eyes peeled. There it is. See that, guys? Flush. Yep. And it stayed when we let off. Now we'll flip it over and do it the other way. You guys see how valuable it is to have like little blocks and scraps of wood and scraps of metal laying around. Everything's all flush. You see the end of the cracks there, the end of the cracks there. So we're just going to drill it out, a little 1/8 inch drill bit. Now that we've got the holes drilled, now we just got to flip it over and get this thing welded back together. These are my settings. I'm running at 420 inches per minute and 20.5 volts using 30,000 solid wire. Now that I'm welding this back together, I've got to be extra careful not to get things too hot. The bearings that are nearby, and the last thing I want to do is fry the grease or mess up the races. It's easy to forget how fast heat can travel through metal, especially when you're so focused on laying down a nice bead. So I'm just taking my time, short welds, letting it cool a little bit in between. No rush. If I end up overheating it, I'm not just risking the weld, I'm also setting myself up for bigger problems later on. I'd rather slow it down now than have to tear this whole thing apart because a bearing seized up. Sometimes it's the stuff that you don't see right away that makes all the difference. And there it is. It's not the prettiest in the world, but it'll do. I ended up making 2 passes just because I was running it hot. I always weld hot anyways, but I was welding it in sections as you saw because I didn't want to overheat this bearing. So I was welding it a little bit, letting it cool, restarting it, and I just kept going around. So there's probably 4 or 5 start and stops. But I did get some undercut on the top part of this because this piece here is much thicker than this piece here, so I put a second pass over it. So this should work pretty good. I mean, we keep reinforcing this thing and eventually something else is going to break, probably a shaft at some point. I mean, we just keep reinforcing it. There's probably 4 or 5 passes. I can't even remember what we did on this here, but we built that up quite a bit too. So yeah, I think he's going to be in good shape, and this should work out pretty well for him. My customer just picked up that part that I fixed for him. I wanted him to leave this because this is a rose bush. I've still got to trim around it, but it went all the way down through with scrub brush, all the way back there, and this came out awesome. He ran it down through. I wasn't home when he did it, but you can see how much nicer this looks down through here. Be easier to mow now, so much cleaner, but it was all like this, all grown up, and he just went down through and boom, cleaned it all up using that thing that I fixed for him. Awesome. That's gonna work great. So for you guys looking to get into welding and fabrication, one of the things that I always like to do is when I receive something like this is find out why. Why did this fail? Because I don't necessarily want it coming back to me if there's something that I could do on my end that would make things better for the customer. And that's why I ask a lot of questions like, how did this crack? Why was this shaft the way it was? And then he said he thinks that his son hit a stump, so that helps me determine what I need to do, if something needs to be made stronger or whatever. And as I said, I ended up going 2 passes around this, so that should make this a lot stronger. It should be a lot less prone to cracking in the future. It doesn't mean it won't, but it should be less prone to doing it. If this is something that you like, please don't forget to rate, comment, and subscribe. Until next week, I will see you then. New videos every Friday. Take care, stay safe, God bless.